Alright, welcome back. Okay, Technotalk just sent me a service manual of this amplifier that I'm trying to refurbish. Well, not today, but I'm going to start today. And Technotalk, I already have the original one. And this thing here is amazing. Look at this. I think hardware manufacturers should do this with everything they sell nowadays. This is magical. Wait. How do I open it here? Look at this. So I've watched a couple of YouTube videos of people refurbishing this amplifier. And so years back, I thought this is way too complicated for me to understand. Well, this part still is, but fiddling with a soldering iron, I think should be something that I will be able to do. And what really amazes me is how modular it is. And yeah, I'm really looking forward to try to get this thing to work again. So, a screwdriver. Yeah. So a manual with the wire, with the schematics. I think that's really amazing. And so no matter what direction I'm going to go with my smartwatch, so I've designed and ordered the version 4 PCBs of the Open Smartwatch, which will be fully open source. And I'm also working on the monochrono, which is, I think I've shown it many times on Instagram, this one here. So I think this one will not be open source, but I will definitely release the schematics because this will help most people try to figure out writing their own software for it, which is half the fun, I think. I'm looking for my screwdriver. Wait, where is it? I'm going to the living room for a second. Got it. And TT is watching and making sure I'm not going to get electrocuted. Let's see. So those two screws come off first. Wait, where did I put my watch? This one. So I'm going to do two things with this watch. So this is my favorite one, and this is the Open Smartwatch from which Linus Tech Tips showed. I think this one's empty. Yeah. So the operating system that's running on this one and the operating system that's running on this one are not the same. But I'm currently writing on a new rewrite of the entire OS that's on this one, which I'm currently working on the monochrono on the left. Will be able to run on both watches or different hardware configurations. And I will make sure that everything that runs on this watch will also be able to run on this watch. But I will keep the fonts and the applications and all the calculations for daylight, like the sunset times or the moon phases or tide estimations. I'm currently planning on keeping those separate in my own ROMs, so people will be able to build their own ROMs or maybe use precompiled binaries. We'll see, but not fully start from scratch. They will have a basic operating system that you can use to have something up and running really quickly. That's two screws. And this pops out. Should I remove those cards first? I don't know. Think no. I think this is more metal than an entire MacBook. So I did some reading on and looking at the YouTube videos how I can work on this ancient piece of technology here. Which, look at this. And things that I need to consider is using a really low soldering temperature. Make sure that I'm using something with lead in it to keep the temperature low, because these PCBs, those boards are so old, they don't really like heat. So I have to keep that in mind. This look at this here, the wiring. So, and I think this bit here is the transformer, the power supply, and I'm trying to figure out where I can measure that it's not going to zap me, because I turned it on half an hour ago and all I heard was a really loud bang and lots of hissing, so I turned it off again. And yeah, I think when they built this, they had in mind that people could work on it or do stuff to it. I will take a couple of pictures first with my phone, so I know where I started and what's going where. And yeah. Yeah, we'll take more pictures, more than one on Instagram story. This is like a history lesson, history in electronics. And I can already see that the PCBs, they were hand drawn. They didn't have computers back then. Or if there were computers, I'm pretty sure they didn't use any for this. And let me check in the schematics. Yeah, they're also hand drawn, the schematics. And you can see here under the, if I hold it up, you can see that it's hard wired to 250 volts instead of 127. Where's the capacitors? Yeah, I think there's nothing on those. We'll see. So I have to check. Or maybe I can add this to your screen as well with an overlay. Let's see. I can quickly switch to my desktop so you can see what I'm currently studying. Where's the desktop? Here. This is the manual that came with the kit that I ordered from Dada Electronics to refurbish this. So I think the only thing I really have to have right now is soldering skills and follow this list of instructions step by step. And so this is what it will look like when I take everything out of the box. And I think this is basically desoldering everything. This is just a bunch of coils that should not show any signs of aging. And should I try to set up a split screen? Would that help you, or would you prefer just to see the desk? I mean, I can paste the link into the chat so you can follow what I'm doing. Where is this? Dada Electronics. So this is the Cord 33 upgrade and revision kit. So this is what I'm working on. First step is to get the power supply out. So, some enablers have PCB connectors. The wires are not connected directly to the boards, as was the case in later versions. Please be advised to not remove those pins. Desolder the wire beam and the mains connections located on the power supply board. Be sure to remove the power supply board's 2 screws. Also remove all components except for the transformer from the board. Okay. Let's try that. So, can definitely see the 2 screws. It's one here and one here. I will do those last. And from the bottom, shut up. I will desolder this wire and this one. All that's connected to the bottom. And those 5 pins here. Let's make some noise. So, soldering iron, where is it? Here we go. And I will turn down the temperature a bit though. I will start with 260 maybe. See if that works. And Technoturk is writing, you can also quick check all transistors in diode mode. We can do that after getting this board out. So that's one. And this one here. Bollocks. No one saw that. To get those bits of solder out later. And that's the 2 red ones from the bottom, from the 250 pin and the 0 pin. Hi, Coldbiter. This thing is amazing. And it can make a lot of noise, but on the lowest settings, the noise cancelling from OBS Studio still works. And it's still strong enough for the little bit of soldering that I'm doing. I think I can give it a little bit more temperature, otherwise all this metal is sucking away all the heat. So I'm using 280. I think I should use a different tip, to be honest. Or sometimes it helps to add more solder to get something off, because the solder has flux in it, and that helps to heat things up. Just like that, and we can lift this up. All right, that's that. Let's put the soldering iron somewhere far away from my hands, because I know myself. And ja, natürlich, I need a different screwdriver. So all the organizing paid off, and I can take out those two screws. That's the first, and no, this one should be the second. And when I'm soldering on the board, I will try to switch to the microscope so you can see exactly what I'm doing wrong. And this is the power supply. And you can see here it says again, no, wait, this way, port 33 and a bunch of numbers. I think this is the model number. And this PCB has no solder mask, so I'm going to take a picture of it first. So just in case I find places where I think it looks bridged, I can check with the picture if that was me or if this is actually on purpose. For example, this bit here. Right, where's the autofocus? Is it possible that some current is still present after I unplugged it? Yes, that is always the case. So before I unplugged it, I let it sit for 15 minutes. Advice from Techno Dirk. We can check if there's anything in it anywhere. I'm running out of disk space. I need a minute. And across the capacitors, this is millivolts, and those are wired. I think they're both diagonally here. Those two millivolts, and again, so yeah, just going randomly across here to see if I find anything, but I don't think so. All right, yes, so this is the kit, and so those are component sizes I'm not really familiar with, because most of the time I'm using 0.6 and 0.3 soldering stuff like this, which is maybe more complex and complicated, but I think easier to solder because, I don't know, because it's small, I don't know. So, but yeah. Time for pictures again, because I'm only doing... Actually, I might do that twice. I have two of those amps. We'll see how it goes. If the result is garbage, then that's on me. Then I will not repeat it. If the result is great, I think I will also refurbish the second model. And taking pictures of the capacitor so I know exactly where the positive sides and the negative sides are. And I'm running out of disk space again. And let me see. I will need to desolder everything. And which parts do I need? I think I will have to open the PDF twice somehow and see which part is which part. Here. So this is what I'm looking at. So replace R500 and R501 with 27 ohm resistors. Red, violet, black, gold, brown. Oh shit! Now I have to read resistors. I should have prepared this in advance and labeled everything. But the manual is great. They've written down the colors, what I need to be looking out for. Any reason you're not using anti-static mat? I don't have an anti-static mat. I don't know why. I think just going by size, I already found the first three components. And 27 ohms is red, violet, black, gold, brown. Red, violet, black, gold, brown. That's this one. So those three by size, I'm guessing. And those two. And replace MR500 with 1.3 watts, 16 volts Zener. What? And there's only one. I think it's this one. Wait a second. I have a picture and it's that one. Okay. And 501, 502 with 1 and 400X. So that's those two. And let me check. C500, C501 with 1000, 1500 or those 25 radio. Let's see what they sent in the kit. That's 1500 and 1500. Okay, that's the two big ones. And 500 C502 is this one. Okay, and we can put all the remaining components away. I will look for a tray. I'll be back in a minute. And I'm back. No need for an ESD mat. Most sensitive parts for ESD are IC. So yeah, I've never used an ESD mat so far, so don't take me as an example, but I'm still having fun and I still get stuff to work. So for hobbyists, I think that's okay. And let's take all these, put them in the tray. What would I do without 3D printed trays that have holes in them? And so those 5 pins will stay where they are, and I really hate desoldering. The manual says I should take everything out, and then let's give that a try. I'm considering to cheat now. Well, let's start with one soldering iron and see if I can wiggle the components out. And at the same time, let me give this thing here a try. Ouch. Let's see if I can give this a bit more of an angle. And let's use the microscope preview to see where we are going here. Yeah, we can see something, but it's not bright enough, right? I can move it closer. Oops. Let's see. We switch the cameras again and see if this helps. Microscope plus desk. So this, why is it so dark? I have no idea. Where's the remote? Maybe I can do something. Nope. Nope, that's also not working. Let's get it closer, see if that helps. And if it's not working, I'm going to only use... wait a minute. No, that's not going to work. Let's switch back to desk only. So, focus. Here we go. Wait, I just had an idea. Just give me 1 minute. Yeah, I don't get an on-screen menu when I'm using the camera with the USB connection, so I'm kind of on the dark, and the buttons on the camera itself don't show anything. I'll give it a second try. Come on. Where is it? This microscope plus desk. No, there's nothing. So I can see my fingers here. Yeah, but no, this is zoomed in so much. You will just see the tip of my soldering iron while I'm soldering. So no, but I have a different idea in my head. I will use this tripod and will attach the camera on the tripod and see how far I can get with this instead of using this. So just give me a minute. How about this? What do you guys think? Everyone here, just turn it like you have to get it leveled though, kind of. Why is it reversed? Let me flip the rotation here. Where's the desk cam? And transform it 180 degrees. This makes more sense. And let me pick the components. And let's place it somewhere where I can still work, where you guys can see, and I can still use the desoldering, the solder film extractor. Yeah. Are you making some PCB? Some really old ones. Yeah, we'll see. That's the first leg. And the second, so that's the first one out. So did I remember where plus and minus was? No. Do I have the images? Yes, so I will use those for references. And I'll just continue. And just by switching from one pin to the other pin, I can wiggle the components away. And I will use the desoldering pump to get all the solder from the board when all the components are desoldered. And number 3, let's have a look. Looking a lot emptier now. I'm a bit confused. Wait a second. They had fewer components on the board to start with than I have. It looks like that's exactly the same board. Wait, I'm just reading here. This feature has never been implemented for the code power amps. Also, this has been omitted by coordinator versions of the 33. For this purpose, C503. That's this one, 504, 503 and 502. That's those two will be removed. That's why. So this is one of the early revisions where they wanted to do some voltage switching signal magic, and that's where those things come from. Yes. And I also marked the plus or minus with permanent marker, just a dot. Yeah, I'm gonna do that. When I'm done desoldering everything, I will just mark it, and then while I'm inserting stuff, I can use that as a reference to see if I messed up. I think I will do it like this. And okay, this is actually going easier than I expected. Which one's the second leg? I think this one. That's this one. At least it's an older board. They tend to be easier to desolder. I think yes, because this is a lot of lead in the solder, and it gets soft really quick. Well, this is just bending those. And where does this one go? Yep, and also this one. And one more. It's this tiny diode here. That's the first leg, and that's all the components desoldered. And so I will check quick on my phone if I bridged anything that's not supposed to be. So yeah, I'm really missing solder mask on this PCB, but I think this is something that wasn't invented 40 years ago. Hi IoT Galaxy, welcome to my live stream. IoT Galaxy, do you also do a lot of stuff with IoT? Wait, I thought I took a picture of the PCB from the bottom, but no. What? I forgot. No, shit. But I might be able to grab something from this stream, because I'm also recording it to check. Because there's a bunch of locations here where I'm actually not sure anymore if this is just me being bad at desoldering or if this was shorted on purpose. But let me check. But it's easier to see from the other side where the traces are supposed to be shorted or not. But let me use my phone's flashlight here. You can see those pins in the middle. Those two are actually shorted by design. I hope. We'll see. And so this is going to be the graveyard of components. And if you have enough of those, you can build your own chess kit. Where's my desoldering thing? It's not here, and it's not here. What? I'll have to go search for it. Give me a minute. Yeah, I'm still looking for my desoldering pump and I can't find it. Where is it? Okay, I can't find it. I give up searching. I will try to do something else, which I also have to find first. I could swear it was in this box here, but it's not. That would have been fun, actually, using it. I still have got more than enough to desolder and clean up over the next weeks in any case, so it will hopefully reappear someday. No. So, anyone who's got more experience using a desoldering wire, feel free to give me some tips. Do I need flux or not? And I will need to desolder every point but those 5 here on the side. Let's see. Yeah, I think I will melt the spool eventually, but not my fingers. Let's try this for a second. If you think I'm doing it wrong, feel free to point that out. Okay, that worked. Yeah, the reason why I didn't cut it into small pieces is because I think I will be using tons of this. Is this actually when I need to desolder? Yes. And if I start cutting it into pieces now, there won't be anything left in a minute. The only thing I did do was I increased the temperature to 340 degrees on the soldering iron, and this actually works better than I expected. But I will cut this a bit shorter. I think I can cut off the parts that are already full with solder. That makes at least a little bit of sense. Yeah, flux makes all the difference. Look at that. I will have to clean the PCB though. I think if you put a hook on this one, you can go fishing with it. There's so much lead in it. And another piece. And some flux. Just a little bit on each point that I want to clean up. Not those 5, I remember now. I think this one and this one. I feel like if you had to pump, you should have used that first and then go over it with the braid. Yeah, but I have enough of this stuff, so. And that's the second strip full. And this one's already empty. And let's start the next. I think I will use one more piece of braid to clean it up. How hot does that pen iron get and how has it been working for you so far? I've really enjoyed soldering with it, and the maximum setting is 400 degrees Celsius, and I'm running it on 310 right now. I have to wait for it to heat up again after fiddling with the settings. I think this one is a bit too big. I will look for a smaller one. 5 millimeters. Yeah. Yep, I think that's clean enough for me. Can you let me show you? Thanks. And let's turn down the solder fume extractor a bit. You only need to clean the vias. What exactly do you mean? Those rough edges around the holes? I think this is from the drills. Yeah, the round holes, those rough edges, oh, they're not actually really all cleaned up, you're right. Well, let's do that again. Yeah, you were right, I just checked them and there's 3 where I'm definitely not going to get any legs through, and that's this one here, this one, and where is it? This one. I'm just going to drown it in flux and then hope they clean up just with the solder braid. I think most of the work in soldering for getting it right is discipline, concentration, and patience. And if you start half-assing it like I've done many times before, it's not going to work out. It's like when you get your first PCB made from Isla and you think I can solder it without a stencil when you go with SMD components, and then you half-ass putting the solder paste on it, you will be desoldering your ESPs really soon. Yeah, I've got this soldering iron here, which has a 3.5 millimeter headphone jack as the power source via USB. And I just turned it on once. You can't even set the temperature, and I confirmed that it can heat up, but no. And the second one I got was this one. This is the USB version, the TS80, and this is the TS100. And I prefer the TS100. It's lighter, and the cable is, well, the USB cables I have for USB-C are too stiff, and that's not fun. Technoturk question: what's the best approach to clean this up? Or what's your favorite approach to clean up a PCB? Okay, I'm back, and I will try to clean this up and see if I do anything wrong. First with the brush, and then with those cotton things. But I have to change something first. I'm going to use those cotton tips to clean it up. And I've watched a really funny video from Louis Rossmann on YouTube. If you want to learn soldering, go follow Louis Rossmann. You will learn way more from him than from me. And there's a piece where he's talking about using these cotton tips for cleaning up PCBs, that people will be saying you will make a mess of your PCB, you will get all the hairs everywhere. And he says something like, are you in control of your cotton tip, or is your cotton tip in control of you? And if you only turn it in one direction, you won't have any hairs on the PCB. And I tried that, and I found out it works really great for me. Of course, if you have any sharp edges, that's going to be tricky. Any reason you don't use a solder station instead of a pen? I don't have a solder station. I don't have the space for a solder station, so I have enough space for a small desk power supply, the microscope that you're not seeing tonight because I can't set it up on this distance here, and the microscope that I'm working with, and that's it. So my makerspace is 2 by 2 meters. Half of it is my office space where I work, and the other half is the second desk where I'm soldering. And that's enough. Sometimes it takes a bit of time to find things or not to find things. Like I demonstrated looking for the soldering pump earlier. And yeah, just give it one more round with the cotton tip. Not that it really needs it, but it's a relaxing thing to do. And these projects are the most fun to work on if it's just something easy to do that doesn't necessarily have to work, but is relaxing. And time for a picture. This time taking, so my dad just wrote me, I need to make sure I'm not mixing up the old and new components, and just put them side by side. I think I'm pretty safe on not mixing up those. And I mean, those haven't changed much. The resistors have a different color, but does anyone know why resistors have different colors here? Like, is this just some manufacturing thing, or is there some further meaning to brown or blue? I have no idea. So I'll be looking at this thing now again, and I will show you the manual. And I will be marking the pins which are plus. Yeah, I have more tools than I need by now, but I mean, if I had more space, I would just get more tools and fill it up with more printers and then have less time doing things. I think the fewer space you have, the more you are really thinking about what you're going to build on. Because if you have the space, you're thinking about how can I use this space and what can I put into the space. Base color of the release is based on the manufacturer. Yeah, I also think so. Oh, well, sounds reasonable to me, to be honest. What's my adding? And mine is okay, this is a picture. So this is from the top. This is from this side. I think the safest approach would be that I end up with the components exactly like the depicted in this picture here. So let's zoom in a bit. So if I end up with something like this, I think I'm on the right track. So I think I will bend the components first before I start soldering, and then I can just add them one by one. So this one needs a bit more. And let's see. Yeah, this fits. And that would match what I'm seeing in the pictures here, minus being that one. And if I compare it to the images, this is the minus pin here. Yeah. Carbon film or the lighter color metal film resistors are blue. Aha. And the second one will go here. Those legs are already pretty bent, but let's see if I go here. And oh, they soldered that one up, right? Okay, I'm doing that. What? Do I have the right component? Let me double check. Yes, I have. They used a different one here in this image. Huh. Yeah, which end here is minus, which one is plus? It has an arrow, so this one is minus. Okay, and minus is the bottom end. Okay. And then this one will go here. It's a pain to start with the tall components, only struggle fitting small things in between them. Start with the low profile components. Yeah, reading it, it makes total sense. But it's more fun to solder big stuff first. I don't know why. Let's put them aside. You're absolutely right. The diodes go over here. The resistors next to here. So let's bend the resistors. So who else had one of these like Cosmos sets as a kid, where you can build your own radio and a flip-flop circuit and build a blinking LED without an Arduino? And everything was neatly explained with like waterfalls and pipes and stuff. And as a kid, I looked at it, I thought, this is easy, this is amazing. So I tried to build my own stuff, and the transistor went up in smoke, and that was that. The rubber side is plus. That confirms, yeah. So the minus is pointing to, wait, this end, which is minus, and the rubber side is plus, which is not where the minus is pointing at, yeah. If a software developer had designed this thing, there would be no markings on it, no documentation, and there would be a snarky comment, it was difficult to build, it should be difficult to use. I think software developers are the worst. That's why I can't code. Oh, I've had people complain about my coding. They might be even watching. Not sure, I don't think so. There would have been a comment about my soldering already. I work with people, friends now, because I'm not working at the same company anymore. And the feedback to one of the first code reviews that I got back is literally, I don't want to work with you. Your code is horrible. Yeah, some developers or teams decide not to comment a thing. And I prefer to write my ideas down with a to-do in front and write the code, remove the to-do, and voila, you have the comment. And just eyeballing how far I need to bend the legs here. And one thing, there's a person you have to leave comments for, and that's not someone else, or it's going to be someone else, and that someone else is going to be you in the future, months in the future, and you will be looking at your code and you will have no idea what you did there, what you've done there. And then you will find your own comments and you will thank yourself for writing comments. Because most of the times you're looking at your own code, I found that comment to be really important. Yeah, sorry. Most of the time when you have to look at your code is because something is going wrong. And the more information you have, the easier it's to figure out what's going wrong. And I think there's also a reason why people have to comment their code, because reading the code to understand what the code does is one thing, but knowing what the developer who wrote the code intended the code to be doing is usually something else. And if those two things don't match, it's called a bug, because the code is not doing what it's intended to do. Okay, let's start from the inside out. I will show you my plans here with the two diodes. They all have the markings here at the top. The resistors don't matter, and then there's minus here in the top, minus here in the top, but minus in the bottom here on this big capacitor. So let's turn on the soldering iron, flip this around again, but first insert the first component. So I'm sure if you can see this, let's give a little more spotlight on it. Yes, this is better. Components to the top. Get the soldering iron heat it up, and as the manual says, use leaded solder and solder everything back together again. First solder, then cut the legs, yes. And first I'm going to solder one leg, and then I'm going to press from behind it and resolder it again, see if it looks right. And then solder the second leg, cut off the legs, and then rinse and repeat. That's the first one. Oh, this is getting hot. And it looks nice. Solder the second leg. And cut the legs off. And that's the first component. Let's repeat once more. Solder the first leg. I'll just push it a bit more through with my fingernail. Yes, there we go. Not perfectly parallel, but meh. And the next one is the diode MF500, a Zener diode with the black marking also going to the top. I should have taken more pictures, before and after pictures. Where else can to take the after pictures? That's one is nice. I think this is the PCB that's the easiest to handle because this huge chunk of metal is like a third hand holding it in place all the time. When can I say it lives? Oh, that will take a few days. I think I have to do this kind of thing 4 or 5 more times. So the preamps, that's 1, 2, 3 more boards that I have to do. I think I won't do them all tonight. And so for the left channel amplifier, right channel amplifier, and I forgot what this one is. And then I have to also refurbish the main amplifier. And so that's 3 components in. Yeah, that will take some time. So when you see the magic smoke, well, every machine is a smoke machine if you use it wrong enough. I turned this amplifier on earlier today, and I had a magic bang coming from the speakers, which seems to be a common thing with this amplifier. And lots of crackling and hissing from the speakers, which I will hope will be fixed with changing a bunch of components after following the instructions. Let's one more in. But considering magic smoke, I remember the first time someone offered to pay me to build a computer for them, and it was a neighbor, and I ordered the components. It had to be cheap, and I assembled everything in front of the neighbor, explaining everything, where the mainboard goes, replacing the mainboard, replacing the CPU, adding new RAM, and everything else remained the same. And I turned it on, and smoke came out of the mainboard. And yeah, I took it home and looked at the mainboard carefully, and then I saw that the jumpers to connect USB were not correctly on from the factory. And in the end it still worked, and they didn't use the second USB port, so that was luck. So that's the small components, and now to the big components. I'm double checking here on the big screen. Everything is, the polarity on the capacitors is right. And minus goes into the top right corner. Yes. So minus to the top right, yeah. That's the second leg. Cut off the legs. And the second capacitor. It also goes to the top right, as shown in the image. I will show you again. This is the desktop. Here we go. So here the minus marking is in the top right. Also here, and there here in the top right also. Yeah, I'm going to definitely keep my camera running when I turn this thing on. It's ready. And if it's magic smoke, that will be 500,000 views on Instagram. And if it's not magic smoke, it will only be a lot less. One thing that I learned with which kind of pliers to use when cutting off the legs for electronics is that they need to have a flat side and an angled side, which is here in the inside. So the flat side always goes towards the PCB, so the force that cuts off the metal leg goes away from the PCB and not into the PCB. Otherwise, if you use it like the first pliers I used that I found somewhere in the basement at home. They were angled on both sides, and you will break the pads if you use those, so they always need to be flat, and you can also cut them closer to the pad this way. Minus is not the plastic end, so minus goes down like so. I'll show you again for reference. Here, this is minus, goes to the bottom end of the PCB, which means the rubber end goes up, because that's plus, and the arrows pointing to the bottom is minus. Yay! So, also hold the finger on it. Yeah, I forgot to do that to get it as close to the board as possible. Now it's right on the board, and then check it looks alright. And then we cut off the legs. That's it. That's all the components replaced or that needed replacing, and everything else needed removing for the power supply. And we'll just move the camera up again for a second. Work. Whoops. Why is it not holding? Now it is. And let's take a look inside again. So this is where the power supply was sitting, and I will have to blow out all the dust and open off solder here. And wait, let me make some space first. Put the power supply aside. Put all the garbage here onto this mat. So this is the graveyard of components that after 40 years of service, I think it's more, 20 to 25 years of service and 10 to 15 years standing on a shelf. And let's get back to this beautiful design here. And this is the on-off switch and the volume knob. And those things here come out like this. So it's the same mechanism that we know from our graphics cards, and it has uneven number of pins. It also says quad 33 in the corner for the right and left channel amplifiers. I think this is genius design. Look at that. We won't see magic smoke tonight, and I'm not planning to see magic smoke with this. 22. Let's number them so we can put everything back exactly like it was. So, bang. So this one gets a tiny F in the corner for front, because I don't know which one's left and which one's right, and this one gets a tiny B for back. So I will know exactly which order I have to put them back inside. So I have to tidy those up. And let me check in the manual. Oh, there's a lot of desoldering going on there again. I will do that on Thursday, I think. Not tomorrow, but maybe Wednesday, we'll see. And then we also need to work on, does it come out? This PCB, which also comes out. So that will be PCB number 4. And they even have expansion cards here on the back, which come out. I will draw a small dot in the corner to know which way around they were inside. I think it's only necessary on one, you will see in a second. It's art from the real fathers of amplifiers. Yes, this is very, very true. So you can open this little hatch here and you can pull out. Oh, and the camera is also giving up. I need to print something for this, I swear. Here. Duct tape. Nah, too easy. Ouch. Printing. And this here also comes out. It's an expansion card, which does stuff. I have to look that up. And also this one here. And this one is the one that needs the small dot in the top left corner. I'll have to go through this recording so I remember. I'll just do a second dot on the other side so I know this edge is the outside edge. And if this comes out, you will see why this is necessary, because I will have to remember which way this thing was inserted, because it looks like a stamp and I'm not quite sure what ideas they had that if you rotate it, it changes the configuration and selects different settings. Either way, I think every manufacturer should take this thing apart and reassemble it, and also provide with the same schematics to make these things repairable after 40 years. And it's a shame that most of the companies are thinking nowadays, fuck you, I'm going to sue you if you're trying to repair something that we built. Buy something new. I'm not going to. I will build my own watch and build my own amplifier from this. Yeah, so this will be 1, sorry, 3, 4, 5, 6 PCBs that need components to be replaced. And there's even more PCBs here on the bottom. Look at this. All right. I hope, yeah, thanks for staying with me for 2 hours now. Yeah, that's enough for one night. Thanks for staying with me for 2 hours. Hope you had some fun watching me with at least one eye or one ear starting the process of refurbishing this. Even the look at how tidy the wiring is. Look at that. That's nice. Yeah, everything. This is, I need to take a picture of this and then send this to I forgot his name. He's on Twitter and Instagram. He's doing these sculptures with wires and electronics and really tiny, clever circuits, tiny satellites, and everything is really neatly bent. And I think it's Mohit. What? I have no idea how to pronounce his name. He builds really nice stuff. I think he will like this wiring. Yeah. All right. See you in a couple of days. I will just do this spontaneously. I'm not sure if I'm going to do this regularly or not. Just, yeah, if you think I should do this once a week or twice a week on a certain day, I think that would work. But right now, I think I will just do it whenever I feel like it. I'm not getting paid here, but it's still fun. Yeah. Just keep an eye on Instagram or, yeah, follow me here on Twitch. I think the notification game